welcome to Two Projects. In this video, we are going to explain the project 2-level LSTM for sentiment analysis with Lexicon embedding and polar flipping. Introduction. Though significant progress has been made improving accuracy in sentiment analysis, a crucial part of natural language processing remains a challenge. A novel strategy to improve sentiment classification is proposed in this project. This project aims to address the difficulties associated with negation and interrogative sentences, which are known to be difficult for deep learning based methods, by combining two-level long short-term memory models with lexicon embedding and polar flipping techniques. To overcome the ongoing problem of arbitrary sentiment labels and complex sentiment representations, deep learning capabilities and lexicon-based insights are combined to improve the accuracy of sentiment analysis. Objective of the project. The objective of this project is to advance sentiment analysis by introducing an innovative approach that combines deep learning methods, notably LSTM, with lexicon-based knowledge. This method aims to significantly enhance sentiment classification accuracy, particularly in challenging scenarios involving interrogative and negation sentences. In addition to the comprehensive workflow encompassing data exploration, pre-processing, feature selection, and model building with a diverse set of machine learning algorithms, we extend the project's capabilities by incorporating various advanced algorithms as extensions. These extensions further enrich the project's capacity to tackle intricate sentiment representations and provide users with a powerful tool for practical real-world sentiment analysis via a user-friendly Flask-based web interface integrated with SQLite. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements needed are Anaconda 3 and Visual Studio Community version. Now we'll discuss the flow of work. These are all the steps followed to build this project. The first step is importing required packages. This step involves importing required libraries and packages like NumPy and Pandas for data manipulation, TensorFlow and Keras for developing deep learning models, sklearn for machine learning tools and metrics, and Matplotlib C1 for data visualization. The second step is exploring the data set. In this step, we employ exploratory data analysis to better understand the data. The third step is data processing. Here, we prepare the dataset for analysis by handling missing values, converting data types, and potentially encoding categorical variables. This ensures that the dataset is in a suitable format for further analysis. The fourth step is visualization using Seaborn and Matplotlib. In this step, we employ Seaborn and Matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is data cleaning. In this step, we perform tasks like tokenization, removing stock words, and handling text-specific data issues. This prepares the textual data for further analysis. The next step is feature selection. In this step, we identify and select relevant features or attributes that contribute most to the sentiment analysis task. The next step is vectorizing the sentence. Here, we convert textual data into a numerical format using count vectorizer, representing word frequencies for each sentence, making it suitable for machine learning models. The next step is splitting the data to train and test. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model learning, while the testing subset evaluates the model's performance on new data. The next step is building the model. We have used various machine learning and deep learning models in this project. The first model used is logistic regression. Logistic regression is a simple yet effective linear classification algorithm. It is used here because of its simplicity and interpretability. It serves as a baseline model for sentiment analysis. The second model used is random forest. Random forest is an ensemble learning method that combines multiple decision trees to improve predictive accuracy. It is robust and capable of handling non-linear relationships in data, making it a good choice for text classification tasks. The third model used is AdaBoost. AdaBoost is another ensemble technique that focuses on boosting the performance of weak classifiers. It is used to enhance classification accuracy, particularly when other algorithms struggle with certain patterns in the data. The next algorithm used is SGD classifier. Stochastic gradient descent (SGD) is a simple optimization algorithm used in this classifier. It is efficient for large datasets and can handle a variety of loss functions, making it useful for text classification. The next algorithm used is k-nearest neighbors (KNN). KNN is a non-parametric algorithm that classifies data points based on their proximity to neighboring points. It can be effective in capturing local patterns in text data, making it a suitable choice for sentiment analysis. The next algorithm used is decision tree. Decision trees are used for classification tasks by recursively splitting the data into subsets based on the most important attributes. They can handle non-linear relationships in data and are easy to visualize. The next algorithm used is multinomial naive Bayes. Multinomial naive Bayes is a probabilistic algorithm well suited for text classification tasks like sentiment analysis. It is based on the Bayes theorem and handles word frequency distributions effectively. The next one is support vector machine (SVM). SVM is a powerful algorithm for binary classification tasks. It works well with high-dimensional data like text and seeks to find an optimal hyperplane to separate classes. The next one is gradient boosting classifier. Gradient boosting combines weak learners to create a strong learner. It is effective at reducing bias and variance, making it suitable for improving classification accuracy. The next algorithm used is MLP classifier. The multi-layer perceptron (MLP) is a deep learning algorithm with multiple layers of neurons. It can capture complex relationships in data, which can be beneficial for sentiment analysis. The next one is voting classifier. The voting classifier combines the predictions of multiple Bayes models, logistic regression, random forest, and the SVM to make a final prediction. It leverages the diversity of these models to improve overall accuracy. And the next models used are LSTM, RNN, GRU, and CNN. These deep learning architectures are used to capture intricate patterns and sequential dependencies in textual data. They are well suited for sentiment analysis as they can handle long-range dependencies and nuanced language expressions. The next step is training and evaluating the models. In this step, we employ the preprocessed dataset to train previously mentioned models. These models learn data patterns and relationships. Subsequently, we evaluate model performance on a separate test dataset. This evaluation step helps ensure that models are accurate and reliable for real-world use. The next step is Flask framework with SQLite for sign-up and sign-in. In this step, we implement a web framework using Flask and integrate an SQLite database for user registration and authentication. Users can sign up by providing their information and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. Upon user input, the given text undergoes pre-processing to classify it as a negative or positive sentence. The trained model is then utilized for prediction, and finally the project's outcome, whether the input text is classified as negative or positive sentiment, is displayed through the front-end interface, providing a user-friendly and intuitive experience. This is the comparison graph. In this graph, on x-axis I have algorithm names and on y-axis I have accuracy. And we can see the voting classifier is doing well when compared to other models in this particular project. We will be using this algorithm for classifications. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file which contains algorithm information which will be loaded into the project code during runtime to utilize the trained models. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And this is train dataset file. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open the Anaconda prompt. Use the cd command followed by space and paste the copied path here. And hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address and the port unless configured differently. So now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up button. Click on it. If we are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly sign in by clicking on sign in button. As I already have an account, I am clicking on sign in button. So it has redirected us to the sign in page. Give the credentials, username and password here. I'm giving my credentials. After giving the credentials, click on login button. So it has redirected us to the classification page. And here we can see an input box where we have to give the inputs and the application will classify it as positive or negative sentiment. So I'm giving the input as have a good day. And click on analyze button. So here we can see the results. The statement is classified as positive sentiment. So similarly, we can give an other input and get the classifications. Click on home. So this time we'll give an other input. So I have entered an input here and now click on analyze. So here we can see the sentiment. It has classified it as negative. Again click on home. We'll give an other input. So I have given another input this time and now click on analyze. So we can see the sentiment as positive. Similarly, we can give inputs and get the classifications for each input. So the conclusion here is the voting classifier outperformed all other algorithms in our sentiment analysis project in terms of accuracy and resilience, making it the best performing model. The ensemble method successfully tapped into the advantages of these models by mixing classifiers from logistic regression, random forest, and support vector machine. Its excellent performance emphasizes how important ensemble techniques are for improving sentiment categorization accuracy. Additionally, our project's friendly graphical user interface powered by Flask and connected with SQLite enables users to easily input text for sentiment analysis. This GUI is a useful tool for sentiment analysis in apps that use natural language processing because it not only improves accessibility but also shows how practically applicable our approach is in real-world situations.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.